Okay, in today's Lab 6, we are going to work with a DC motor control on the practical board. Okay, so this is the board of DC controller, DC motor controller. This is the controller board circuit, and this is the DC motor. Okay, so it will spin if you give different inputs through this board. And this board has a DC power supply, and the entire platform is based on the LabVIEW. Okay, so this is a LabVIEW we are going to use, and we can open the project called DC MCT motor controller and modeling, okay, which is the first lab over here. So the first lab is to do the modeling of this DC motor, which means we need to find a specification like the static state gain and the rising and falling time constant, which is the tau of this DC motor. Okay. So over here we can calculate the steady state gain by this K equals to delta Y and delta U. Delta Y is the DC motor output over here, so delta Y is from the top, the steady state, to the initial state, and the delta U is the input, which is a step function. Okay. So calculate the maximum U minus minimum U, and we can get this K. And for tau, we can calculate by about 70% or 1 over square root of 2 of the entire voltage, rising voltage. So it's about 70% of the entire delta Y, and the rising time is the tau. Okay, and same as falling time. So over here we have this model already built in the LabVIEW. So once we open it, we can see this interface, and the default settings are the same as the in the right menu. And if we simply run it, you can see it will give the similar waveform. Actually, it should be the same waveform at the right side. Okay, and when you run it, you can see the motor is spinning periodically in a periodical pulse function. Okay, so it will run, stop, run, stop. Okay, and what we can try the auto scale of Y, so we can have a better look. Okay, and this is measurements graph, so we can auto scale Y and change the cursor over here, and this is cursor 2. We can put it over here, a little bit left and a little bit left. So the difference between cursor 0x and cursor 2x is the rising time, or the tau. Okay, the time constant. Say this is like 70%, it should be smaller, so it's about 0.2 seconds. And over here we can try to change the cursor Y over here. Okay, so that's the maximum Y, and this is the probably we need another one. And if we go down, it's about 0. Okay, so we can do the calculations by with the subtraction to get the delta Y, and similar to delta U as well. Okay, but also we can use eye observation to give some approximate number. Say this is since the amplitude is 1 amp, so it's positive 1 and negative 1 surrounding at both sides of this offset 2. Okay, so the 2 is the average value, and positive 1 plus 1 makes it 3, and negative 1 makes it 1. So the delta U is 2, and this delta Y is about 70 or 60 to 70 between, and this is 0. Okay, so the delta Y is about 30, 35. So let's pick 30. Okay, let's pick 30 over here, and let's run it again. So now it looks like the simulation result is closer to the actual output. So which mean, but there's some offset, okay, between the simulation and the output. It's because the offset's making over here, this is 1 volt, and if we change the amplitude to 2 volts and leave the offset to be 2, which means the average is still 2, but positive 2 makes it full and negative 2 makes it 0. So we will basically cancel out the minimum input value to be 0. Okay, and let's run it again, and you can see that offset is almost cancelled, but the simulation result is actually going larger than the actual output. Okay, so which means 30 is not the exact number, and we need to adjust it to, it's a bit above 100 divided by 4, so it's about 25, 26. Let's try 26. Now we have a very close simulation result and the actual output. Oops, let's continue. One more time, clicking. So this is the actual model, the K and the tau we are looking for. Okay, so it's about 26 and 0.1. Okay, and so basically that's the model of this DC motor, and these numbers you need to write down for the future use. Okay, over here the first lab is to remember when you use the default value, this is 1, and when you run it you need to write down the numbers of delta y and delta u and do the calculations, and also use this measurement graph to measure the tau. Okay, so it's the delta between these two, and also the delta y if you want to do the measurement. Okay, and then do the calculations for K and tau. And then for the second one, you input that calculated K and tau and observe the difference between each other and make proper adjustment to make the simulation result is the same, equal to the actual output, and compare the difference between each other. Okay, so this is for the first one, DC motor modeling.